Okay, welcome guys. So in this video, I will prove this Cayley's theorem. So Cayley's theorem is a theorem in a group theory, which is also interesting. So I want to make a video. Be sure to subscribe to my channel. Okay. So and leave a comment, say that you like or not like, or what do we learn in this video. So theorem says that if G is a finite group, so basically G's order is called n, which is greater or equal to 1, and it's finite. Then the G is isomorphic to a subgroup of Sn, which is this n means a symmetric group with n letters. Okay, so this theorem is not astonishing that from intuitive point of view, you say that you can view a finite group with just subpermutation, right? So it's not very astonishing that G will be isomorphic to a subgroup of Sn, right? But this theorem tells you that in order to study all the finite group, one can just study one can just focus on the symmetric group. Although this theorem is not practical because the symmetric group is also very difficult in general. Okay, so but the proof idea is very amazing, I think. So let's call symmetric. So in order to prove this, we need to somehow first realize Sn as connected with group G, and then we build up some map to prove this theorem. So symmetric group G, I can define symmetric group. So now I can forget about the group structure. So symmetric group is defined to be a function, a set, right? Each function is basically from G to G, which is a bijective. Okay, and it's obviously that the symmetric group G is isomorphic to Sn, right? Because you just permutation n letters, right? So the number of functions which you can start from G to G, which is bijective, is basically n factorial, right? So it will isomorphic to Sn, right? So basically, it's easy to see, right? Okay, so now we can construct a map that's called T from G to symmetric group G, and we know it's isomorphic to Sn, and we want to use the first isomorphism theorem. Okay, so with the first isomorphism theorem, so let's suppose T is a homomorphism, then we should have that G quotient kernel of T will isomorphic to subgroup, right? So will be image of T basically is some subgroup of Sn. So we want to show that so we want to find T. We want to find the T such that right. The first is T must be homomorphism, right? In order to use this theorem, and the second is that the kernel T should be 0, right? So that means should be really 0. So it means that T is injective. Basically, this. Okay, so how to find the T, right? So basically, we want to given any group element, we want to construct a function, right? Map into symmetric G. Okay, so the idea is very easy. Let's suppose you give a group G. Then I should give you a function, right? So I call this function fg. Fg act on any x in the group will be gx, right? So g act on x, right? G times x. Okay, so obviously, Fg belongs to symmetric G. Okay, the reason is that the Fg is bijective, right? Because you only take a G, so you take a G from left side. So basically, it's still 1 1 and it's still on 2. Okay. And also, let's prove that, and it's obvious and the second is that T is a homomorphism. Okay, so because f of G, f of h on x will be g h x, right? So basically, it's f of G h x, right? So it's g h x, right? So this is homomorphism. Okay, so finally, we want to prove that the kernel T is 0. Okay, so this is also easy because suppose we have two G and H, and we have a function which is the same, right? So it means that f of gx is the same as f of hx, right? For all x in the group, but that means gx equals hx, right? But x is in a group, right? So x has inverse element, so that means I can times inverse x inverse from left, so I get g equals h equals h, right? So this T is injective. Okay, so combine all of the things we know. We know that okay, fine, T is homomorphism, kernel T is 0, so T is injective. And by our first homomorphism theorem, we know that G quotient kernel T will be image of T. But image of T basically is definitely a subgroup of Sn, so this proves a theorem. So we prove that G right? So this G is isomorphic to subgroup of Sn. Okay, I will see you guys in the next video. Be sure to subscribe to my channel. Thanks.